So this is an example of what homework one will look like. This is a different data set, but I'm doing all the same steps that you'll need to do for homework one. So I'm going to go through briefly and just point out a few different things. The first is we want to enter a data set by hand. Again, we only want to do this for small data sets. So you'll say data, and then this is where you put what you want to name the data set. I decided to name it any name. For input, I tell that the variable names are hours and sales. Data line says, hey, pay attention, here comes my data. Put in your data semicolon. So remember, everything has to end in semicolons, run. Now that usually doesn't look very pretty, so if you want to look at the data, you can do proc print data equals any name, colon, run. That's how you do it by hand. More often, you're going to want to import a data set. There's actually a few different ways you can do it. I like just doing a simple proc import. So we'll do proc import data file equals, and then you have to have your file path. So if you remember in our last video, we talked about how to find that file path. So usually it will be like home and whatever your username is. And then if you have your files in different folders, you'll have to adjust your file structure. For us, because you're in my class and enrolled in my class, what you do is you'd come in here to your files in home and you look for my share filings, and I'm the instructor's U590, so go under there and look for the data set you're looking for. So in this case, I think I'm doing PA-BMI, so I could double click it. And notice it will give me some suggested code to reference it, and it will tell me the file path that I can use, and I can copy that, and that helps me get the correct file path. See, so a few notes. The DBMS, again, just tells it it's an Excel file, so you tell it here that it's Excel versus something else. Out, what do you want to name the data set? And I decided to name it PA-BMI. And get names equals yes, that's actually the default, so you can leave that line out and it will still work. It's just saying my Excel file has headers, it has the variable names in the header. And again, I printed my data so I could look at it. Now, as a note, the underscore is the only special character you can use in the name. So if you try and do a dash or a hyphen, anything, it's not going to work for you, but you can use an underscore. Okay, you can see the data, and then I would say before you ever do any kind of problem, you should stop and do this step. You should say my data equals PA-BMI. So what did you name your data set? Your X variable equals physical activity, and your Y variable equals BMI. Because if you're trying to just go back and change code, sometimes you're like, wait, what variable was here? And I've accidentally switched my X and Y variables just when I'm plugging them into places. So it just kind of helps if you write this down and then look at it as you do the rest of your code. First thing we want to do is you'll have to make a box plot. A box plot comes with proc scplot, tell it your data set, and they do VBox for a vertical box. Tell it the variable you want. I want to do physical activity, run. Here's my box plot. But let's say I want to add some labels. Okay, so same thing. I tell it I want to do it. Now I've switched variables. I'm going to do BMI. I can do title 1, give it a title. I can do a y-axis label, give it a y-axis, and run. Now note here, again, green is for comments, dark blue is for the procedure you want it to do, blue is for options, and the black or gray is kind of what you tell it. And anything you see in purple is a text string. So we use that for like titles. Sometimes we might use it if we have anything that's going to be more of like words. Okay. Now there's two different ways in SAS you can make histograms. You can use proc scplot, and it doesn't really matter which way, you're going to get the same results. You tell it the data, you tell it I want to do a histogram for physical activity, and if you just do that, it's going to give you just a histogram. So let's come back to our SAS file to see what that might look like. And you can see that I did put this in the shared file so you can look at it if you want to. So we're looking at method 1 for the histogram. So if I comment out these other 3 lines just to see what it will look like if I don't have them. So you can just put a little asterisk in front of it and then it will go until it hits a semicolon. So a good way to say what will my code do without actually having to delete the code. Oops, I always forget I didn't run this yet. It hasn't imported my data. So I don't think I ever run a file without having some kind of error of some semicolon I forgot, something here or there. Don't get discouraged, just keep working on it. And let's see what we got. We had the box plots. Okay, let's go back and run that histogram again. So you'll see my histogram. It doesn't have a curve. It doesn't have any titles because I didn't put it there. It does put my X variable name, but PA isn't very informative, so I should probably give it a better label. I could even change the y-axis label if I wish. But we did want to have a normal curve, so we say density, so it's like a density curve, just what we call density curves that we learned about to do for each distribution, a normal curve, a t-curve. So we want to do a normal curve, that's the type. Remember, a slash means I'm going to give you options. I can give it a title, I can give it a subtitle if I want. If I don't give it a title here, it might keep giving my titles from my previous things. So the titles often carry through from step to step, and sometimes then you'll get titles that don't apply. So pay attention. Usually it's just easier to give everything a title. We can look at the second method for histogram. So instead of using proc scplot, you can do proc univariate. So proc univariate does a lot of summary statistics. Okay, I tell it my data set, and then I have this no print. I'm going to comment out that no print for a minute and see if it will run. I'm not sure if it will run since I put the comment with that semicolon. Nope, do not. I need a new semicolon. Okay, it didn't like me just commenting out no print, so I just deleted it for a second. So if you look at the univariate output, it gives you a lot of things. It tells you n, like how many you have in there. It gives you the mean. It gives you standard deviation, skewness, kurtosis, all kinds of things. Okay, it kind of repeats them. You have quantiles, you have extreme observations, lots and lots and lots of things. You don't really want all of that. In fact, the only thing we wanted was this histogram. So let's go back to our code. If you don't need all of that summary output, you can just say no print. That just will save a little bit of space, a little bit of time for you having to look through it all. And here's my much nicer histogram. It still gives me some output, but not as much as before. So looking at this, it looks mostly symmetric. I mean, it might kind of be a little bit off, okay, but it's fairly close to normal. It's easier to see though if we make normal quantile plots. So we're going to do proc univariate data again. Okay, again, I'm going to say no print. I don't need all of that output again, especially after I did it once. And we'll do a QQ plot. So if you do QQ plots, there's actually more ways to do QQ plots than just a normal quantile plot, but the normal quantile is the default, so it will know you just want a normal quantile plot. And I want it to do it for physical activity, and I also want it to do it for BMI. So luckily, it'll just let me put in all the variables I want it to do, and I don't have to do each variable individually. So my QQ plot for PA, that actually looks like a very straight line. I would say that is very normally distributed. That looks great. My QQ plot for my BMI, it doesn't look bad. I mean, maybe a little bit here and there, but I would say it's still fairly close to normal. In fact, I didn't ask you to do this on your homework, but I did find a little trick to make a normal quantile plot with the reference line, if you want to compare it to the line. So it's the same thing. I tell it I want a QQ plot and an option with a slash. I'm going to do normal, but I want it to estimate my mean and estimate the sigma of the data. So otherwise it says I'll draw a normal curve, but you have to tell me the mean and standard deviation. And I'm saying, well, estimate it from the data. And for whatever reason, they made that by default draw the line for us. So again, physical activity, that looks fantastic. In fact, it's hard to find data that looks that good. For BMI, I mean, you kind of dip here and there, but I don't see anything in there that would be alarming. I would feel just fine saying this is normal enough to do what we want to do. So what do we have left? We made our normal quantile plots. We can do a scatter plot. So a scatter plot, again, is just proc SG. And we tell it the data set and scatter, and you have to say my X variable is PA, my Y variable is BMI, and run it. So we have a nice scatter plot. If you want to go through and add some titles and make it prettier, you can go back to our section 1.3, our SAS crash course, and look at those notes for ways that you can make it a little bit fancier, but it wasn't required for this homework. Now let's say that we had a scatter plot, but what if we wanted a regression line? This is actually really nice. Notice the code looks exactly the same. All I have to do is switch scatter for reg for regression, and it will give me the scatter plot with the regression line. So there's my regression line. Notice it says down here, this blue line is regression. That line kind of feels a little redundant, like you should probably realize that's what it is. So I can come back here to my data step and I could say, no auto legend. So I kind of like how it pops up. Here's some things you might want to put here. And if I run that, my legend's gone. Because you don't always need a legend if you only have one thing. You can find your correlation. So we do proc core, tell it the data set, and what variables I'm interested in. So right now I'm interested in PA and BMI. So I can run that and it'll look like the output you have on your notes. You can see, well, PA with PA has a perfect correlation of 1. That's no surprise. Those are kind of useless. You don't need to compare it to itself. But for the BMI and PA, we're at a negative 0.385. So that means, let's see, it's going to have a downward trend, but it's kind of a weak association, which makes sense based on our scatter plot. The points weren't that close to the line. But what you might notice is what happens if I comment out this line. If I comment out that line and run it, it does the same thing, but now it does it for any variable in the data set. So basically I'll do it for all the data set variable in your data set. Some variable or data sets might have 10, 20, 30 variables and you might not really want to run it all. So if you want to be specific about which variables it should run, then you just say variables var PA and BMI. And that's it. Just a few things to note. Make sure there is a style guide for your homework. It's on the homework page. You do have to follow that. It makes it just easier for the grader to grade everything if everything's the same formatting. Also, it's not bad for you to have to learn to follow different style guidelines. If you have any questions, please come ask them in class. That's why we have class. That's why we're doing a lot of videos outside of class, so you have time to ask questions in class.